Okay, so this is just a little additional video onto what we were talking about future value and compound interest in the previous video. We're going to investigate a pretty interesting concept that arises when we talk about compound interest. And through doing this example, it's going to really give us an idea of how compound interest actually works and what it means to have interest that is compounding. Now we're going to look at an example here. So this is a $200,000 investment for 10 years at 6% per annum. Okay, so we're going to look at two cases. The first is something that is compounding quarterly. And another one that's compounding monthly. Okay, so if we go through and do this question, you can pause this and have a go on your own, but I have my present value here, I have my number of compounding periods, and I have my rate. What we're going to do on the left hand side is, first of all, we're going to note that this is compounding quarterly, so 4 times in 1 year. So what that means is the number of compounding periods are going to change from 10 to 10 times 4, because it's 4 periods every year. So that means I'm going to have 40 compounding periods by the end, and my rate, since it's 6% every year, by finding the rate of a quarter of a year, we're going to divide this by 4. So we're going to take 0.06 divided by 4. Same thing on the other side. We're going to look at our, because this is compounding monthly, so 12 times every year, we're going to take 10 and we're going to multiply it by 12. That gives us 120, and our rate is going to give us 0.06, and because it's monthly, I'm going to divide that by 12 because there are 12 months in 1 year. Now, if we pause here, you may be looking here and going, okay, cool, like we've done the same thing. It's the same rate and number of compounding periods as in the question. So surely we've changed these kind of relative to one another. We should get the same answer, right? Now, what actually happens is when we substitute this into our future value formula, let's take this one on the left hand side, my future value, I'm just practicing substituting this in. I get 1 plus 0.06 divided by 4 to the power of 40. That thing gives me, to 2 decimal places, $362,000. Sorry, $362,803.68. And if we do the same on the right hand side, our future value is going to be still 200,000 times 1 plus 0.06 divided by 12 to the power of 120. And that answer gives us 363,879.35. We get 2 different values, which is really kind of curious. Now, to understand what's happening here, we need to think back to the definition of compound interest. The easiest definition, the layman's definition I like to think of, is interest on interest. So interest on top of interest. So thinking back to what we looked at when we did this in, it would have been the year 9 or year 10 course, we took, for example, an amount which was, I don't know, let's say $100 at, 6% for 3 years. And what we basically did was we said, okay, after the first year, we take our 100 and we times this by 0.06. And then just times it by 1, which just gives us that. This was the simple interest idea. We took this, and then the difference was that the second time interest was charged, it wasn't just on the 100. Interest is charged on the principal as well as the interest. So we charge, let's just write this again. We take our 100 times 1.06, which we were charged on the first go. We are charged interest on top of the entire thing. Then when it compounds again, we're charged 1.06 or another 6% on top of the whole thing. That's how we get, for example, 100. Instead of writing it this way, we just wrote this times 1.06 to the power of 3 because I have 3 of these. And when I times the same number by itself 3 times, I can say I'm raising it to the power of 3. What is happening here is that even though the rate and the initial number of compounding periods are the same, the thing on the right hand side is compounding far more times. Sure, it's at a lower rate because we're dividing by 12 instead of 4, but this whole snowball effect of interest on top of interest is happening a lot more when we compound monthly as opposed to quarterly. So it's only really a marginal difference. It's in the thousands when we compare the two answers. But if we think of compound interest as interest on top of interest, the more compounding periods we have, for example here compounding monthly 120 compared to compounding quarterly 40, the higher our future value is going to be. If we brought this even down to daily, you can try this on your own, but say we looked at compounding daily. So your n would be 10 times 365. And your r would be 0.06 divided by 365. Try this. Try substituting it into this future value formula we've been working through and see what you get. You'll get something that's even higher than this thing. Because even just looking at this part, 10 times 365, that's 3,650. We are compounding that many times. Even though the rate is tiny, we are getting this snowball effect of interest on top of interest a lot more. This is why banks typically, when they give you a home loan, for example, they will compound the interest daily so that they get more money in interest at the end of the day. If we can understand this concept, we can really get our head around how compound interest works, which is a very prevalent thing and will be in your day-to-day life once you finish school. We are dealing with interest on top of interest. And this is why we get this really interesting case coming up here. Thank you so much for watching, and I'll see you next time.